everybody, welcome back to the channel. If you know from episode 1, we had machined our tool forks as well as our fixture from episode 1, and we noted that we didn't tap the holes yet because I was waiting on my taps to come in to use the Tormach compression tapping head. Well, those tools have come in. The vise is still set up on the mill, so I'm going to go ahead and take advantage of that while the vise is zeroed out. So we're going to go ahead and tap these. But I wanted to reiterate some things that we had in the soft jaws or the fixture. And that was these holes right here. These holes are about, they're 0.265, I believe, in depth here. So that allows the pass-through of the tap to be able to penetrate when it passes through to give a good clean-cut hole. And then, as I noted, the inline screws will clear in here. So what we'll do is we'll go back into manufacture, and we have already set it up in here with our tool bit, and we'll go ahead and edit so we can go over it. We have an M4 thread with a 7mm pitch. It has set for, the recommended is 500 RPMs, which is what we're going to use. We've already selected our geometry that we wanted, and we've also told it that this hole at the top of the chamfer surface is our origin point, so when we go out I can probe this hole to zero it out. We have set the hole bottom plus a negative 200 thousandths, so that's pass through of the tap that'll go down into those cut pockets. So that's a pass through for that, and as noted, these two don't matter. And then it's finally we are tapping, so we wanted zero dwell with the tapping, compression tapping head. So now that we've gone over this, we'll go out in the shop, we'll run some cycles and get these tapped up, and then we can move on to the fork disc, machining the fork disc. And once we're finished with this, we'll come back and we'll go over this on the screen. Hey everybody, welcome back. Alright, so we're out in the shop, we're at the Tormach, and I just got done using the Tormach probe and went ahead and set the origin 0 on the part in the fixture. I have a few extras that I wrote P on. These were not up to snuff as far as what I felt that needed to be used in this machine, so I had a couple of them. So I wrote P on there as my practice parts for doing the taps, just to make sure everything's good. I've already used this head before on tapping other items, and actually I made the nice little wrench for my vise with a nice spinny handle, so that's what I use the tapping head for, to test it out on the wrench. So we got it set up. We have the compression tapping head set up, the M4 spiral tap, and I've already preset the offset in the path pilot. So at this point I'll go ahead and get the the tool all set back up, and we'll come right back as soon as I'm ready to go. Alright, we are ready to go. The tapping head already installed, even though before I started the program I went ahead and put it in place. I had to set the ratio to the low on here, which by the way I need to set it on here for the spindle range. I have forgotten to change it from low to high and machined another part, and luckily the lower speed wasn't a big deal. It actually machined quite well. I just cranked up the RPMs to be able to get the speed that I needed, but a little bit more speed. So anyways, I have it selected for the low range, and we're basically ready to go at this point. It's zeroed out on that origin, so we'll hit the go button and see if we break a tap. Voila, looks like it did it. So we will take this out and see what it looks like. And then I'll put the camera in the machine and we'll tap another one of the practice parts again, and see it in action. Get a towel here to wipe it off. And the threads look absolutely stunning. So let's see if we can see this or not. There's that side there, and there's the side there. So voila, so there's that one. So we'll load up another. Like I said, we'll come back with the camera installed so that you can see it in place, and we'll run from there. So, all right, here we go. That's simple. So we'll get this unloaded, and being you got to see all of this, there it is, fresh off the machine. Voila, the threads look awesome. So, all right, ladies and gents, so I'm going to finish tapping all these out. And then when we come back, as I noted earlier, that we'll come back and be ready to start doing the machining for the fork disc that these forks attach to. Alright, here we are at my fusion screen. This is for the fork disc. This is what holds all the tool forks that we've machined in the previous episodes. So here we're starting out with a piece of 1/2 inch thick stock, which ended up measuring out at 0.518 in thickness. So we have it basically centralized in there with an offset of 50 thousandths. So it'll have to surface the top to get the trueness. So we're doing a conventional method of passing. Like I said, there's 2 passes on here to give us our surface. I'm not going to go too depth in the interest of keeping this video at a relatively short length. So we start out with a boring pass first on a 3/8 end mill, and this boring will bore all the way through the material, so that way when we flip this over to machine the other side, we have a reference hole to probe off of. We go with an adaptive for cutting the top section of it. This will cut each one of the pockets. We'll kind of go over this for some of the reasoning why I did what I've done on here. Alright, so 6,300 RPMs at 52, almost 53 inches a minute. This is the default coming from Fusion. I've been using that, and so far I've been happy. I know it's a little more conservative in comparison to the feeds and speeds calculator. So, but I'm using it, and it seems to be pretty good with me so far. The depth is the selected contour, which will be the very bottom of the part, and then I'm doing a 40 thousandths is my optimal load. The reason why I've done 40 thousandths is because this is a long unsupported part, or the stock is long and unsupported underneath the center. So to reduce chatter or flexing in the part that would create chatter, I'm trying to reduce the amount of cuts on here. So I left 20 thousandths on the radial and 0 on the bottom surfaces, so that way I can come back and do my finishing pass. And next would be our contour. Let me get back here. Contour. We contour this first, and then we contour. Come back to and then we contour around the actual part, leaving this much stock left. There's a lot of stock left. When it comes to all these holes on here, I chose to use end mills versus a drill bit, simply because I wanted to make sure that I wasn't going to drill into the vise, since there was very little clearance on the underside of it. So I used end mills to create all these bores because I didn't have enough pass through for the drill bit. So this is being done with a 3/16 end mill for these larger holes. and there is a 10 thousandths pass through on the bottom side of it. So when we surface it, we make sure we get it good and clean. The next would be all these holes. These were done with an 1/8 inch 3-flute end mill all the way around, and then finally we finish up with chamfers all the way around on the main surfaces. So after now this, we'll go to the shop and we'll go over the machining there. Hey everybody, welcome to the shop. Alright, so we're at the Tormach 770M, and we have a piece of 1/2 inch plate aluminum. I want to tell you a little story about this stuff. Maybe in your area you can take a look. I live way out in the country, so for me to go to a metal supply place is a journey. I have a place called a Metal Supermarket. They're over in Knoxville, and they have a scrap bin basically, and I go in there periodically to get some aluminum or steel or whatever, and they had a sale going on in their scrap bin, and they sell all these drop aluminum pieces for $1.50 a pound, which is a steal. So when I go there, I look at their scrap stuff and determine what's good that I could use. You know, sometimes I get really nice bar stock, far more exceeding the price of what, you know, I'm going to be paying for it when it's in the drop shelf. 90% of it's 60-61 that I'm looking at. There is some steel, but this particular piece that I'm machining on here is probably a $15-20 piece if you was to order this from a place to do this machining, and I probably paid $3 for it. So my last visit I got 86 pounds worth of aluminum, and we're talking some really nice bar stock that's in excess of $100 if you to buy that size piece. So really good deal. So just a tip, Metal Supermarkets, to take a look, see if you got one. Even if it's not on sale, it's still far cheaper than getting, you know, the full price for a brand new piece. It is brand new, and they're in really excellent shape. So anyways, back to it. We're not going to film the whole machining process of this. Is just the top half of the fork disc. It's almost an hour's worth of machining on here, so I'm going to do a little bit of it, and then when we come back, I'll have the top section machined. This is going to be a two-part. I'm going to machine the top. I got it set up in my vise, and then after that I have to machine a set of fixtures or soft jaws to clamp the disc so I can machine the opposite side. Typically I wouldn't machine, you know, this much material as a waste, because the disc is only like a 1/4 inch in thickness, and this is 1/2 inch material. But I happen to have this. Like I said, it was cheap, and so on the other side I'm just going to have to do a lot of surfacing. So anyways, we'll get started, and when we come back you can get to see it, which will, for you, will be seconds. Okay, we are all done with this. This is, so far for me, this is the largest as far as surface area part that I've machined on here. I have a threaded hole that's supposed to go here, but I was unsure if it was going to collide with the jaw block, so I didn't cam that in. I'll tap that manually since it is a single hole. Not really worth setting up to do a single hole. But this is the fixture, or the tool fork. So each one of these goes in position like so. These pockets here are about 3/1000ths of an inch larger than this, so it gives a good you know, clearance to make sure it could go in there. It wasn't going to be a super tight fit, because I'm not worried about, even though when it's in there right now it's awesome, there's hardly any play at all. So at this point all we have to do is machine our soft jaws so we can clamp this disc the other direction and then surface off the excess material. So our next up will be machining the soft jaws, and then we'll surface that, and that'll finish this video. All right, we're going to do a quick down and dirty. This is one of the halves of the soft jaws for the fork disc. This is 1.25 inches by 3/4, 60-61. It's been notched at the top to hold one portion of the disc. The other jaw will be mounted on the back side of the vise block. It's screwed in with M6 threads. I put in a hole right here. I'm going to bore it or drill it with an 1/8 inch drill bit, since I already have a drill bit set up in the tool table. Even though the actual hole in the part is for a 4mm screw, if I decide I need to index that plate for any reason, then I'll drill this out for an indexing pin. And basically, let's see if we can turn that on. And oops, give me a moment here. No, I don't have it in here, so sorry about that. Anyways, the fork plate, where all the 4mm holes in it, this will go up into one of the holes and allow me to index it, so that way if I need to do anything like tapping or anything like that, as I noted in the previous machining cycle, there's only one threaded hole in there, and I decided to do it manually versus doing all the rest. But anyways, we'll go back out to the shop and we'll get these machined up. Hey everybody, welcome. Alright, so what we have here is we've already machined the fixed soft jaw. So I'm going to set up the camera and we're going to machine the moving soft jaw. Alright, here we go. Alright, now it's time for the indexing drill. Being I have an 1/8 inch already set up, that's why I didn't do all the extra work for making it the correct pin size. I figured if I needed an index, I'd already have it pre-drilled. So here we go. Alright, ladies and gents, that's it. Alright, here we are. We're getting ready to surface, take the extra off of this plate. And in the cam section I noted about going ahead and making that bore go all the way through. Well, this is the reason why. That way I have a reference point to set when I set the origin, so I can zero off that hole. Being this is a round disc, once you center it to that, then the rest of this means nothing. So I basically have this plate roughly, I basically took a ruler and measured from here and measured from here to try to make it even, because there's so much extra material that when it surfaces, you know, being square, it's going to fall off anyways. So the only function that I have set up in the cam is to surface the top of this and then to put a chamfer around the outside diameter of the disc, and then that is it. Like I said, in the soft jaws, I did index it in case I wanted to do something later, but at this point I'm not worried about chamfering all the other holes on the opposite side. So we're gonna run with this. So let me get this all set up and then I'll run the machine. Alright, here we go. Sorry, that was uglier than I thought. It's getting water stuff coolant all over the machine. So sorry. Well, when we're done, I'll shoot a video of it. All right, it's all done. The surface finish is good, but it's not the best. I made a finishing pass on this because this part is so thin and it's so wide that there's more chance of the chatter to happen, especially the bigger face mill. And I only did a single 10,000ths finishing pass. Probably should have did maybe 2 or 3 of a much lighter finishing pass. But I mean, it's just some light scoring, nothing, no grooves or anything like that. I can just see where there's a light amount, and that could have been from the when I was taking the main passes were coming off and the chatter. It wasn't chattering very bad, but so I didn't think too much of it. But for the most part, this is done and we can move on. So let me take it out of here and then I'll see if I can get a better camera angle on the part so you can see it. All right, we have the part off and hopefully get some decent light so you can kind of see the surface finish that was on there. I got my nice chamfer. Probably should have chamfered that, but it's not. It doesn't feel bad. I'll just deburr that by hand. But for the most part, she's ready to go. So this is for my ATC project on the Tormach 770M. Please like and subscribe, help the channel grow, and continue to watch as we produce our parts for our ATC. Thanks, and we'll see you on the next episode.